Chapter 4. Can you believe it? We're already into Chapter 4. And Chapter 4 is really short. We actually just do 3 lessons in Chapter 4, and then we'll have a quiz. This first lesson is all about graphing relationships. You're going to do a lot of listening and picking things out, but not so much writing things down or even drawing things. A little bit of drawing. So we know that graphs can be used to represent a lot of different situations. And the trick here is to be able to relate the graph from the picture to the words and back and forth. And what's really critical is that you pay close attention to the labels on the axis. So don't assume you know what the labels are. Make sure you're really reading them. If you're constructing a graph, make sure you really label them. Some key words to pay attention to, and once again, you don't have to write these down, just read along with me here, is if we're looking at if the description in words says something is constant, it's staying the same, it's normal, that's just going to be a horizontal line. Okay? It just goes straight across. It's not changing. Okay? If something rises steadily or increasing, we're looking at a slanted line up to the right. If it steadily drops or decreases, then we're looking at it heading down to the right. Rapidly rising, then it should go steeper. Less rapidly, it would go more close toward flat. And the same thing with rapidly going down. It's going to go steeply downhill. So go ahead and read through this description with me, and then you're going to pick out the graph that you think matches the little story. The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph representing the situation. And all of these show time versus temperature. So think about which one you would choose. Dun, 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 dun. Have it picked? Okay, don't change your mind now. So let's talk through it. So we're looking for one that increases steadily at the beginning. Well, graph A stays the same for a while and then increases. Graph B stays the same for a while and then increases. Graph C is the only one that increases steadily at the beginning. So I'm thinking it should be graph C. Let's make sure it matches the rest of the story. Okay. Then it remained constant, so it should be flat, and it is. At the end of the day, it increases slightly before dropping sharply. Okay, so B is also missing the increase toward the end before the drop, and A does have an increase, but it has a big increase, not a little one. So graph C should have been what you picked. Okay, whoa, I think we skipped like several slides. Oh, maybe not. Continuous graphs versus discrete graphs, and this you do need to write down. It's the vocabulary at the beginning. This is a really important concept. Continuous graphs have connected lines or curves because the data can be measured continuously, meaning the line actually means something. There really is meaning for every little infinite point along the line, like time versus temperature. You can keep measuring time down to smaller and smaller and smaller amounts. You can measure temperature out to many, many decimal places if you really wanted to. Okay, so that everything has meaning along that line. Discrete graphs only have distinct points on them, and the values between usually whole numbers are not included because they don't make sense. Right? So here's a good example. We've got theme park attendance, years versus people. Right? We can't count people in fractional amounts per year. So we don't want just a line going down because that would sort of indicate that we could have 12.5 people or 2.5 million people at there, and we can't really have that. So that's the big difference. Dots for discrete, when we have things that can be counted individually, and continuous when we have data where there really is meaning for all the little fractions and decimals along the line. Now we're going to do a quick sketch, so you can draw a little graph, right? It should have arrows on it. Like it's only got the positives, so you don't really need 4 quadrants, really just 2. And we're going to sketch graph for this situation. And we're going to decide if it's continuous or discrete. Now these are not the kind of problems where everybody gets the exact same picture. Yours might be a little bit different than mine depending on how you interpret the story. A truck driver enters a street, drives at a constant speed, stops at a light, and then continues. Okay. So we're looking at time here on the x-axis, and on the y-axis we're looking at the speed of the truck. It doesn't really say that directly in the problem, so it could be a better written problem. And at first he's entering the street, so I'm going to assume maybe he's turning or coming from a stop. So maybe at 0, maybe really close to 0. Notice you don't have to put numbers on the line for this one. And so he enters the street, so he's speeding up as he enters the street, and then he drives at a constant speed, and then he stops at a light. He doesn't just slam on the brakes, so he slows down to a stop, and then he continues. So then he speeds up, and he continues. It's going to look something like that. Oh, we forgot. Is it discrete or continuous? Let's go back. It is continuous because we can measure his speed very precisely if we wanted to, and time is also something that we can measure continuously. So that would be a continuous graph. Now on to the next one. Aha, true or false? This graph is continuous. Answer in your own mind. Thinking. Okay, you should have your answer. This graph is not continuous. It's discrete, because we're looking at the numbers of books sold, and the bookstore does not sell half books and eighth books and 0.27s of books. They just sell whole books, and they've got the dots there on the graph for you to see how many books they sold each day. That is discrete data. Another true-false. This graph is discrete. Okay, this is about Jamie and her keyboarding class. We're looking at how many words she can type per minute. And once again, we have dots on the line. She only types a certain number of words per minute. This is true. This is a discrete graph. Okay. One last true or false. This graph is continuous. We have a water tank draining, so he's got the valve open, and then he opens another valve, so this speeds up. This is true. This is a continuous graph. We can measure the exact level of the water at any point in time if we want to. So all of the data points along the line have meaning. Okay. And really, you still have only written down those two definitions, and sketched one graph. That's all you've had to write down so far. So don't panic if you're feeling like you must be missing things. You're not. Both of these graphs on this slide show a relationship about a kid going down a slide. And graph A has the distance from the ground versus time, and graph B has speed related for time. Look at how they are not the same. You really have to pay attention to what you're being asked to graph. And graph A really looks like the slide, because the kid goes up. Here's the kid, stick kid, and then he's going to get closer to the ground, and then, eventually he hits the ground, He lands on his tushy at the bottom. Okay. But graph B is looking at the speed, and at first he's not going that fast, but then he picks up speed and he's going really fast. His speed is increasing, and then as he gets toward the bottom, his speed levels out, and then when he gets to the very bottom of the slide, his speed rapidly goes to 0. So here we have increasing speed, and then constant speed up here at the top. For a little while he's going the same speed, and then a rapid decrease in the speed. So don't just draw what you think the picture looks like based on what the object is. Oh, it's a slide. It should look like a slide. You've got to think about what you're comparing. Okay. Writing a situation, this is one other thing you're going to do. Just a couple sentences that tell what's going on. So on this graph, we have time versus speed. So we should be talking about somebody running or biking or driving. And we can see that the first thing that happens is the person slows down, then they go constant, and then they come to a complete stop. So maybe your story is something like The bicyclist sees a bunch of cars nearby, so he slows down a little bit so that he doesn't run into everybody. And then he continues pedaling at the same speed. And then he sees a stoplight, so he comes to a complete stop because it's red. Okay? So something like that. This section should feel kind of fun, kind of easy. It's about pictures and stories. It's not really about calculations or anything like that. On this one, same thing about writing a story. Okay. We have pizzas bought on the y-axis and students on the x-axis. And notice for a while, as the students increase, the number of pizzas doesn't increase. But then all of a sudden, it jumps up, and then it stays constant for a while. So my story would probably be, as students arrive, for a while, the number of pizzas we had ordered was perfect, right? And we just kept the same number of pizzas, and then more students showed up. We finally needed to order more pizzas, and then those pizzas were enough for, an increasing number of kids. If more kids kept coming, we'd have to jump up again and order more pizzas. All right, that's actually it. We're going to stop right there. As for your notes on page 51, keywords for graph segments, you can go back if you'd like and add a few more in, but I'm not actually that concerned about you filling anything in for those keywords. I think you'll be good to go as is, and we'll do a little bit more work on this in class.